This is the second review for Unit 4 Geometry. First question says, for each of the following diagrams, decide if the triangles are similar and by which similarity theorem, or if they're not similar, say why. So the first thing I'm going to do is remind you that these are the three reasons why we could have similar triangles. Either we have two angles that match in both triangles, we have two sides with an angle in between, or we have three sides. So the first thing I'm going to do for each of these is notice that we have 34 and 34, which is one angle. You cannot assume that the other angles are the same, so first I'm going to solve and find that by knowing that all three angles add to 180. So when I find the missing angles, I found one was 60 and the other's 91, so there's really only one angle that's the same between them, so these are definitely not similar. In the next one, I'm going to do the same thing. First of all, I notice that I have 51 degrees here. Both of these are 90, so that's one angle, so I need to find the missing angle. And I get 39 degrees because they all add to 180. And since this one's 39 and this one's 39, this one's 90 and 90, if I find the missing one, this will be 51 degrees. So these are similar by AA. Oh, yes, similar. Sorry, similar by AA. So this is yes, they're similar. This was no. And this was because of AA if we use the correct column. In C, we have the middle side by reflexive. So these triangles are actually similar because of SSS, but more than that, they're actually congruent. So they are similar, but they're also exactly the same size. So they are similar and congruent. For the last one, I note that this angle and this angle are the same because they're vertical. They also give us the arrows here, which means if we follow a Z like that, we get alternate interior. So these should be similar, at least by AA. I am also going to check sides. So the 10, if I was comparing, is bigger than 6. So I could set up 10 goes to the 15, and I'll check that as a ratio. The same way that 6 goes to 9. So I'm just going to check both of those as decimals real quickly and make sure they're the same. So I get 0.6 repeating, and this one's also 0.6 repeating, or you could reduce the fractions to 2/3. This is 2/3. So they are similar, and you could actually say AA or you could say SAS because they have a side with an angle with a side. So either one of those is acceptable. So in this question, they're asking us to find the length of HO, and the first thing that they really should have told us was that the triangles were similar, or given us some information. Otherwise, we can't really solve it. So I'm going to assume that they're similar, and if this is the little triangle, this is X and this is 6. If I look at the bigger triangle, this whole side is 26 by adding, so the other side would be X plus 19. And if the triangles are similar, we can set up proportions using the sides that go together. So I'm going to set up the X to the X plus 19 the same way that 6 goes to 26. Just make sure you go in the same order. If you go from the left to the right, you have to go from left to right with the 6 and the 26. And then you just have to cross multiply to solve. So the final answer is 5.7 for X when you do all the work cross multiplying and solving. So in this question, the first thing they ask us is they say that the graph shows a dilation from JKLM, and that's this bigger one, to J prime, K prime, L prime, M prime. It should have a prime right there. They want to know if it was an enlargement or a reduction. Well, if I went from JKLM to the prime, notice the prime is smaller, so it was a reduction to go from this to that. They want to know what the scale factor was. So the first thing I notice is if I try and find a length that I can actually count, this would be the easiest one. So this is 2 units. If you notice over here, JL or KL is 4 units, which means the smaller one is half. So the scale factor is 1/2. The next part says that if the scale factor was K equals 7, that would mean 7 times bigger. They would want to know what the new coordinates would be. So first I labeled the original JKLM coordinates, and 7 times bigger is just going to multiply all of those numbers by 7. So I'll fill that in for you real quickly. So in question number 4, they're asking us to rotate this triangle 180 degrees. And it doesn't matter which way you go, because you could go clockwise or counterclockwise. So first I'm going to plot that, and then the next part says that we then need to dilate it with a scale factor of 1/2. So first I want to find the coordinates of the rotation. So when you do that, you get these coordinates for the new triangle. And then the next part asks us to dilate it with a scale factor of 1/2. And since I listed the coordinates, it'll be very easy to find the new coordinates. So I'm just going to cut each of these numbers in half, and I'm going to plot that little triangle. So that's the little red triangle that I just got. Then part B says reflect what we just got, the newest one, over the y-axis. So first I want to label real quickly. So these are my shortcuts. So this was this was P prime, and this was little z prime, and this was y prime. And now they want us to reflect it over the y and then dilate it again by multiplying 3 times bigger. So first I'm going to dilate it over the y for you. So this little triangle here is a reflection across the y-axis, so I folded it over. The last thing we have to do is it says we need to dilate that by a factor of 3. So first I'm going to list the coordinates, and then I'm going to multiply them by 3. So the end result is this triangle right here. So I took the little pink one, I wrote the coordinates right here. I tripled all of the coordinates to be 3 times bigger, because that's what it says. Dilation of scale factor 3, and then I plotted them and labeled the coordinates, so be careful that you label correctly. This question says we need to find the total area of the rhombus. So one thing that's important to notice is that there's a right angle right there in the center of the diagonals. So I see 4 triangles, and I see there's one right here. And all we need to do is find the area of the triangle by doing base times height divided by 2, and then multiply by 4. So that's going to be 12 times 8, divide by 2. So the area of this triangle right here would be 48, but there's 4 of them. So each one of these would have an area of 48. So to find the whole area, we just multiply by 4. So the final answer for the area is 192.